My name is Hans-Christoph Ries and I'm working at SARM for over 10 years now. I'm in the research group of Christian Eigenbrot in combustion engineering, and currently I'm working on fire safety in space in a project with the name FLARE-G. We want to find out the flame spread over thin PMMR samples under microgravity conditions. And furthermore, we want to know how different atmospheres affect this flame spread. So we change the O2 level and we change the ambient pressure so that we have an O2 level that is comparable to Earth, but lower pressure. Since we want to burn a thin layer of PMMR, we have a sample holder which holds a thin sample in place, which we can either ignite on the top or on the bottom. And this all happens in a box in a combustion chamber, and this chamber is flowed through with oxygen and nitrogen in a special mixture regarding the experiment we are doing, and flows in this direction always. So if we ignite on the top, we have flame which spreads against the flow. It's called opposed flow in that case. And if we ignite on the bottom, we have concurrent flow. And that's about all we're doing there. First of all, it's fundamental research. So there might be possibilities to use this, or there might not. This is always the case. Our idea is that the either can research on other kinds of material, either other PMMRs, which are different in color or whatever else, or in just in other thin materials which are used in spaceflight. And the other idea is a broader, bigger idea, to get a prediction method for fire hazards in spacecrafts or in space exploration missions. Because we have different atmospheres in spacecrafts and in a possible moon habitat or a possible Mars habitat, which different levels of O2 and different pressure levels. And both affect the flame spread and affect the fire hazard. So this is what we are aiming for. I used the drop tower with the catapult start because I need a longer time than the drop alone. And with the drop alone, we would have 4.7 seconds, which wouldn't be enough for the flame to get a steady state. And with the catapult, we get up to 9.2, 9.21 seconds of flame spread, and the flame is steady at that point, usually.